So this is now going to be part 4 of the atom test. First question was how many orbitals in a p sublevel? So looking back at this sheet, the p sublevel has 3 boxes, so the answer would be 3 orbitals. And when you put people into the boarding house, which room did the manager fill first? So the boarding house model is the sunny room and the pink room that we had here. So did he put people in the sunny room first or the pink room first? It was the sunny room. So you filled up the S sublevel first. Oops, you couldn't see what I just pointed to, I'm sorry. So this was the sunny room, and this is a pink room, and people went into the sunny room before they went into the pink room, and that's true for atoms as well. Electrons go into the S sublevel before they go into the P sublevel. Okay, so which one is an excited atom? Excited atoms have electrons that are in a higher energy position than usual. So usual means that you start with 1s and fill it up, and then 2s and put 2 in, and 2p with 6, and then 3s with 2, and then 3p with 6. But if you had, say, a 1s with 1, and a 2s with 2, and a 2p with 3 or something, then that would be an excited electron that has moved from here to a higher level. So we're looking for something that doesn't fill in the correct orbital. We want an excited atom. So 1s2, 2s2, 2p2 doesn't seem right because you normally have 1s2, 2s2, then 2p6, 2, 4, 6. So this is your excited atom. So the other two do what they're supposed to do. They go 1s2, 2s2, 2p6, 3s2, 3p6, and then 1s2, 2s2, 2p6, 3s1. Those are both correct filling orders, but this one has some empty spots in the P, so it must be excited. Okay, for atoms in the ground state, before you begin putting electrons into the P sublevel, you've got to have the S sublevel full. And what that means is before you get in, if I'm putting electrons in like I was earlier in a different movie, if I'm putting electrons into these guys, I don't start this room until the sunny room is full. So the S sublevel must be full would be my answer there. All right, when 3 electrons enter the P sublevel, do they pair up or do they choose to be in orbitals by themselves? So if I'm going to continue on, now this is not bromine, but if I continue on here and put electrons in, they go in one at a time. They don't pair up until they have to pair up because there's already one in each orbital. Okay, so they choose to be in orbitals by themselves. Which is highest in energy? It'd be the one with the highest coefficient. That'd be 3p. And what that means is on this guy right here, so here's 1s, 2s, 2p, 3s, 3p. So we're looking at 1s, and 3p was a choice, and 2s was a choice, and 2p was a choice. So from these 4, which is the higher energy, the one that's highest up the chart, so it'll be 3p. All right, in a 3p if the 3p sublevel is full, but the 3s sublevel is empty, so that means we've started this one before we finish that one, the atom must be excited. When I say this one and that one, sorry, I forgot to toggle over. So if the 3p is full, but the 3s is empty, so that means you've got a scenario that looks like this, but the 3s is empty, then there must be some electrons that move from here up to there. So that would mean the atom was excited. All right, when putting electrons into atoms, they go from low energy to high, or from high to low, they go from low to high. So they start with 1 and go up. And if the sunny room and the pink room on the same energy level were all full, that would look like this, just using the third energy level as an example. So how many are there? 2, 4, 6, 8. That's the most you can ever have in the outer shell of an atom in normal circumstances is 8. So in aluminum, how many energy levels are full or partially occupied? So aluminum has 13 electrons. And I've run, I have my, we're all 2 full. So if I do this, that's aluminum. 2, 4, 6, 8, 10, 12, 13. So how many energy levels are full or partially full? Well, it would be the first, the second, and the third. The first and second are full of electrons, but the third is only partially full because I could still put more electrons in on aluminum. Let me show you that again because I'm off screen. Okay, so aluminum. Here's aluminum. That's what I have my hand there. I forgot to check my computer screen, see if you could see it. So here we go again. How many electron energy levels are full or partially full in aluminum? You have 2, 4, 6, 8, 10, 12, 13, and they're in the first, the second, and the third energy level. The first and the second are full. The third energy level is not full. So the answer is 3. First, second, and third. And if the pink room contains 3 electrons, how many will be spinning in opposite directions? Well, none of them. Here's an example of that. Here's 3 electrons in the pink room. See how they all spin the same way? And in the electron 2p6, 6 is the number of electrons. So the 2 is the energy level, or the floor. The p is the type of room, or the sublevel. And the 6 is the number of electrons that are in that sublevel. Now we're back to aluminum. So I'm going to just grab another copy of that. So here's aluminum. So we have 2 in the 1s. Aluminum has 13 electrons. Its atomic number is 13. So there's 10 electrons. 2, 4, 6, 8, 10, 11, 12, 13. So aluminum has 13 electrons. How many are in the highest energy level? So the highest energy level would be the third floor, wouldn't it? First floor, second floor, and then the third floor. Make that a little bigger. So first floor, third floor, third floor. How many is in the third floor? 1, 2, 3. 1, 2, 3. Which is higher in energy, S or P? Look over here. See how P's are higher than the S's? The P's higher than the S. The P's higher than the S. So the answer is P. Which, when they're in the same orbital, do they spin in the same way or opposite way? So in the same orbital means that they're in the same box like this. So one's up, one's down, and they spin in opposite ways. Now this is sodium in its ground state, not excited. So if it's not excited, you wouldn't expect any empty spaces. So the 1s should have 2 in it, and they all do. The 2s should have 2, and they all do. The 2p should have 6, and they do not all 3 have 6. Which one has 6? That one. So that's its normal state, and that's the answer to that question, because you want the one that's in its ground state. By now you should be realizing which one of these don't exist, or doesn't exist. So there is no such thing as a 1p, is there? Remember, on the first floor there's a kitchen. It wasn't a sunny room, or it wasn't a pink room on the first floor in the house models. So there's no such thing as a 1p. All right, and oxygen, if you're looking at oxygen, I'll draw oxygen at the bottom of this sheet. So you have 1, 2, 3, 4, 5, 6, 7, 8. So it looks like there are 2, 4, 5, 6 in the second energy level of oxygen. And that would be 6. I didn't think I'd been through all these questions already, but it looks like we've made it through all of them. Let me double check. Yes, we did. All right, so that was the end of part 4 of the test.